multiply by 3. We're currently dividing by 3. And we need to get rid of that, so the opposite of dividing is multiplying. So 3 cancels out there, so I have x equals 24. Alright, so then number 2, we've done problems like this, especially last unit, where we have fractions and we have to get rid of our denominators. Yep, so we multiply by the largest denominator.
Really quickly, guys, does anyone need a stamp sheet? Is there anyone that lost a stamp sheet?
Alright, so multiply by your largest denominator on both sides. So my 6's cancel over here, and I have just 5. And then over here, when I put in my calculator, remember this is the same thing as 1 over 3. So 6 times 1/3 is just 2. And then how do I get n by itself? Divide by 2. My 2's reduced to 1, so then I have just n equals 5 times. And that's my final answer. Questions on those ones so far? So again, when we have fractions, the way to eliminate those fractions is to get rid of my denominator. I can multiply by whatever is in the denominator. Alright, so then for the third one here, again, we want to start off by multiplying by the largest denominator. Alright, so we multiply by 7 on both sides. And 7 over 3 doesn't reduce. If you do 7 times 1/3 in your calculator, it stays at 7/3. So we still have 7m over 3. And then my 7's cancel here, and I get 2.
You finish, I'll give you up to 1.
Alright, we still have a denominator, so we need to do that again. Multiply by my largest denominator, which this time is 3. My 3's cancel here, so I have 7m equals 6. And then I can solve for m by dividing by 7. So my 7's reduced, and I get m equals 6 sevenths. That's my final answer. Alright, questions on that? Okay, so again, carrying the same process through for number 4. I need to get rid of my largest denominator. What's my largest denominator here? In a few minutes. It's also really hard, so we have to think about that. What is my largest denominator for number 4? 4. So we multiply both sides by 4. Alright, so my 4's cancel over here and I get just 3. Now if I put in my calculator 4 times 1/2, or 4 divided by 2, I get just 2. And I still have in parentheses the y plus 2 on top. You could actually go ahead and distribute your 4 and then reduce each individual fraction, but this will save you a little bit of time. Alright, so then I need to distribute my 2. Again, 4 divided by 2 gave me 2. So I have to distribute now. I have 2y plus 4 equals 3. And subtract my 4. This is just like all of our solving problems we've been doing for like 5 months now. And then divide by 2. So I get y equals -1. That's my final answer. Alright, any questions with those 4 warm-up problems?
No.
Okay, so let's take a look at the homework. Go over questions on that, and then we'll take our mini quiz. Okay, so today's topic that we're learning about is called compound inequalities. So having looked at the notes just briefly, does anyone know what a compound inequality is?
2 things.
Yeah, it's 2 things. We have basically 2 inequalities. Compound usually have more than one thing compounded together. So a compound inequality is we have 2 inequalities that apply to each other. So we have 2 options for this. Our 2 inequalities can either be separated by an and or by an or. So by the words and or by the word or. Alright, so for an and inequality, This means that x satisfies two different conditions. X is greater than 0 and it's less than or equal to 4. So what would be a number that is greater than 0 but also less than or equal to 4? 3. Yeah, 3. 3 is greater than 0 and 3 is also less than or equal to 4. So an and inequality, which is a compound inequality, has those two conditions that are combined together by and. Now an or inequality is written as two separate inequalities. We have x is less than -1, or x is greater than 2. So what would be a number that satisfies that? X is less than -1 or x is greater than 2? We want to satisfy one of the conditions. Because it's not possible to satisfy both, right? If there's no number that is less than -1 but also greater than 2. So we just need to satisfy one of the conditions. So yeah, 3. 3 satisfies us. 3 is greater than 2. So as long as it satisfies one of the conditions, then it is a solution. Okay, so for our and inequality, we see it looks kind of like a sandwich. Sandwich, yes. Yes. So sandwich and so we have it as one inequality. We can write it as one inequality. Okay, gentlemen, we need to stop. Whatever's happening over here, cease and let's listen. If we can't handle it, then we're going to start moving people. So an and inequality can be written as one inequality. Notice it's put together. An or inequality has to be written as two separate things because x cannot satisfy both conditions at the same time. Alright, so the graph of your or inequality should have arrows that go in opposite directions. Alright, so our or inequality have arrows that go in opposite directions. Because you'll see once we graph it, x is less than -1, that's an arrow point that way. And x is greater than 2, it's going to be pointing in that direction. You can think of this also as oars on a boat. When you're rowing a boat, I don't know that any of you guys have ever gone canoeing before. Oh, that's not good. You have your oars going opposite directions. They're going in opposite directions. So as when we graph one, you'll see how they kind of go in opposite directions. All right, the graph of your and inequality should also look like a sandwich. It's just one line, one piece. It has two endpoints and the line in between them. Okay, so our first view, it says write an inequality that represents this statement. Number 1 says x is less than 8 and at least 3. Alright, so x is less than 8 and at least 3. Yeah, so that means it can be 3. If you have at least $3, if I give you, or let's make it something more exciting. Let's say that I bring in
$2,000
cookies. If I give you at least 3 cookies, how many have you had? You have 3 or more, right? It includes 3. Right? If I say, if you give me a smart graph, I ate at least 3 cookies, I'd be like, okay, well, you ate 3, you might eat 4. So you have, that includes that 3 there. Alright, so x is less than 8 and at least 3. Notice our keyword here, and. That means it's going to be written as one inequality. It's going to look like a symmetry. Alright, so we like to always put our smallest number on the left side and then our largest number on the right side. So we have 3 on the left and we have 8 is on the right. And it says x is less than 8. So what inequality should I put between x and 8? Less than. X is less than 8. And then at least 3. Yeah, x is greater than 3. So the open side, the mouse should be facing towards the x. Because x is greater than 3, but it can also include 3. So 3, we read this as 3 is less than or equal to x, which is less than 8. Meaning any number in between 3 and 8, including 3, is a solution. Any number that satisfies both of those. So what would be a solution to this inequality? Just name one number that means.
7.
7. Yeah, very good.
No, it's like 15.
Alright, so number 2. It says x is greater than 7 or less than or equal to 5. Our keyword here, or. Or equal to, yeah. So this is kind of
Do you have
together.
to put a line on both or
Just this one here. Only the 5 has the or equal to. Alright, so x is greater than 7 or less than or equal to 5. So when we have or, 2 separate statements here. So x is greater than 7. X is greater than 7. Or less than or equal to 5. So x is less than or equal to 5. So pretty much you just write it as you read it.
That's all we have to do. We have to write it. We don't have to like, add a number.
Right here it just says write an inequality. So we're just taking the verbal expression and translating it to the inequality. We will go to where we're actually solving this down the ground. Okay, just review. You can leave it closer. Okay, so name a solution to number 2. What would be a number that satisfies this?
Does it? So it only has to do one.
Yeah.
So 8.
Yeah, because 8 is greater than 7. So give me a number that's greater than 7 or less than negative or less than 5. Yeah, 8 would work, 4 would work.
But where would I put it?
When we graph it, you'll see we have 2 different arrows. And so like number
I would
6
put
here,
it where the
you would put it with the number that it has.
graph is.
These ones actually aren't too bad.
Oh.
It's like you're graphing 2 separate ones in the same problem. Alright, number 3, x is between -4 and -2. So we have it's between, that automatically means we're going to have this sandwich type. It's an and statement. So let's put our -2 on the left side, our -4 on the right side. And x is going to be in between those 2. And you have to flip your inequalities. So Trey actually just asked a really good question. He said, what if, like, so for number 1, what if you would have put 8 on the left side? You can do that, but that means all of your inequalities are going to flip with it. You're applying the property of symmetry again, the symmetric property. You're taking the whole inequality and flipping it around.
So whatever the first number is,
We like to put the smallest number on the left side. The smallest number on the left side. So it's easiest if you put the smallest number on the left side, because it makes a little bit more sense when you're reading it. 3 is less than or equal to x, which is less than 8. I know x has to be something between 3 and 8. Whereas here, you get a little confused because say 8 is greater than x, which is greater than or equal to 3. You kind of have to think backwards. X has to be between 3 and 8. Oh, you're right. Thank you, Trey. Trey just caught my mistake. -4 is less than -2, isn't it? So -4 is actually my smaller number. Thank you, Trey. So -4 is the smaller one. -2 is the larger one. If x is between these, then x needs to be greater than. It's between. X has to be greater than 4, so the open mouth is headed towards x. And x has to be less than -2, so again, the open mouth is headed towards -2. X has to be between -4 and -2, so anything greater than -4 and less than -2. Alright, questions so far? I want you to go ahead and try number 4. See what you get with this guy, and then we'll come back together and make sure you got it. Alright, x is less than 5 and greater than 2. What's our key word here? What's the key word that lets me know what kind? And, good. X is less than 5 and greater than 2. So it's going to be written as 1 inequality. Put our smaller number on the left. So 2 is over there. 5 is over here. X is in the middle. Alright, x is less than 5. And x has to be greater than 2. So x is greater than 2. The larger mouth is headed towards the x. That's my inequality. Alright, how are we feeling about this? Thumbs up, thumbs middle, thumbs down. Feeling okay, but you're afraid I'm going to throw something crazy at you? Alright, so let's take a look at where we have the graph given to us. And then now we need to write the inequality for it. So again, our graph for an and statement is going to look like a 6. We've got our ends here. These are our pieces of bread on our sandwich, and then this is all the meat and cheese in between. Our or statement has 2 different arrows. You can think of this as the oars on a boat. So here's a canoe. Here's someone sitting in the canoe. And here are the oars.
I'm drawing sailboat.
No, yours looks pretty much like
You don't
that.
use those oars in the canoe.
Use oars in the canoe.
use,
You can
like,
have
the
where it
one
has the
oar,
supports on the
like
side.
this.
Yeah, you can do it with one oar. You can do it where it has the supports and you go like this.
Just like
There's like an kayak.
Well, for a
Oh,
canoe, you can just
kayaks
use it when you go back and
is
forth as well.
canoe.
Okay, so number 5, we know this is going to be an and statement. And also,
You get tired.
we have, it's kind of, just like they use the word between here, we have all the numbers between 6 and 10. So you can kind of use that to help you out as well. Alright, so this is an and statement, so I'm going to have my lower number, x, my larger number.
I did actually.
Okay, so if you've noticed our and statements, as long as we've written the smallest number on the left side, which way do my arrows face? The left, yeah. So as long as your smaller number's on the left side for an and statement, they're both going to be facing left like this. So here we have the less than. Also, you can think of this as x is anything greater than 6, so the open mouth should be towards the x. And x is less than 10, so the open mouth should be towards the 10. That's why the inequalities are set up that way for an and statement, because the smaller number is going to be less than the larger number. That's why we have the smaller number on the left side. Okay, is this going to be just a less than or equal to?
Or equal to building.
Right, because my dot is closed, it's going to have that or equal to. So you have a couple of things to keep in mind. First of all, are these open or closed dots? And then second of all, is this an and or or? Alright, questions on number 5. Okay, so number 6, we have an or statement here. 2 separate arrows facing in opposite directions. So I'm going to have 2 separate statements. Alright, so my first statement. What would be my statement for this graph here? What does this represent? How would you read this part of my graph? It is an or, but how would I read this left part of my graph? Like if you had to write an inequality for this, like we did last class.
Less.
Right, x is less than 7. It's everything less than 7. An open circle, which means there's no or equal to sign underneath. Then the second part here, how would I write my inequality for the second part over here? Right, x is greater than 9. It's everything larger than 9. Again, an open circle, so we do not have the or equal to. So this would be my final answer. X is less than 7, or x is greater than 9. That's it. Alright, so I want you guys to go ahead and do numbers 7 and 8. I'll give you 1 minute for this, and then we'll come back together and see if you got it right. For number 7, what did you guys get?
-3 on the left.
-3 on the left,
+1.
+1 on the right, x in between.
And then
Good. And are either than or equal to?
1.
Yeah, 1 we have the or equal to. So this is -3 is less than x, which is less than or equal to 1. Very good. All right, Joe, what did you get for number 8?
Also, what I got was x is less than -2.
Good.
Or x is greater than 2.
Anybody have anything to add to this?
Or equal.
Good, very good. Or equal to. Good. X is less than -2, or
What?
x is greater than or equal to.
I wrote them, but I just wrote like things back.
Did you go -2 is
Yeah.
greater than x? That's fine. As long as you have -2 is greater than x. Your open mouth should be towards the -2 since that's the largest value. So I recommend, guys, when you're writing your OR ones, always do your X on the left side, and also that helps you out with the arrows to know which inequality to use. It's pointing to the right, so we know it's to the right. As long as X is on the left side, you can use that trick. All right, questions on that? Okay, on to the back side.
What about 9, 10, 11?
Flipping it over to the back side.
9, 10, 11 on the front.
Oh, are they really? Whoa, that's weird. Okay, well, let's do 9, 10, and 11.
What does it think so?
All right, so sketch a graph of inequality. So here they've given us the inequality. Now we have to graph it.
There's still water on your paper.
All right, so number 9, they've given us the inequality. Now we need to sketch the graph. So we're just going backwards of what we've just done. So -2 is my smallest number there. 5 is my largest number. We can see this is an and. So we can see this is an and. So what type of circle are we going to have at -2?
Circles.
Closed, right. So let's go ahead and extend out. When our number lines are so small like this, I like to go ahead and extend the line at the number I'm using. Alright, so -2. And then our higher number is 5. Again, make sure these are labeled. If it's not already labeled, label that that is 5.
It's already labeled.
Okay, we have a closed circle at 2. What type of circle do we have at 5? Closed as well. And this is an and statement, so that means it's everything in between. X is between -2 and 5, so all numbers between -2 and 5. So what would be a solution to this inequality? Like, what there? So for inequalities, we have a bunch of different answers. What would be just one number that would work? 2 would work. 2 would work. Good.
0.
0 would also work.
1. 3.
Awesome. Good.
Maybe.
All right. So number 10. Again, we have another and statement. So let's put our mark at 3.
You just guess.
I'm looking at the paper.
And we have at 7.
No, you didn't.
It's not supposed to.
Again, go ahead and label these. And at 3, open or closed? Open. And Muhammad at 7, open or closed? Very good. And we have everything in between. This is an and statement. So just those numbers in between. All right, number 11. Now we finally have an or statement. So we should see your arrows go in opposite directions. Make sure your X's are on the left side. If it's not on the left side, flip it around so it'll help you out. So I have at -3. So let's mark that. So is this an open or a closed dot at -3?
One is close. I mean, one, yeah.
Okay, -3 is a closed dot. And X is less than -3. So I want to see everyone pointing which direction are we going to go?
That.
Which way is your inequality pointing? That way. What is a number that's less than -3? -4? Yeah, so where is that to the left? So we go that way. Alright, so there's one of my inequalities, and now I need to do the other one.
Oh, so these don't.
Right, or go in opposite directions. Oh. Alright, a +1. And this is an open circle. That doesn't look like a circle.
Hey, it's much better.
And which direction is this going to face? To the right. My inequality arrow is pointing to the right. This is going to point to the right. What is a number that's greater than 1?
2.
2. 2 is to the right of it, so we go to the right. Alright, questions on that? Okay, I want you guys to do 12, 13, 14. I'll give you 2 minutes for this, and then we'll come back together and go over that.
Wait, that's
Okay, so number 12, we have x is less or equal to 4, so we have a closed dot on negative. Oh, positive
negative
4.
4.
Positive 4.
Slow down.
And then at, oh, I need to make it a little bit smaller, otherwise it's going to run into each other. And then at positive 6, well, actually, this isn't more. Let's just stick with the left side. So x is less than or equal to 4, so that's going to be to the left. Less than to the left. And then x is greater than or equal to 6. So again, a closed dot. Everything greater than that. Number 13, we have an and statement. Ooh, so with this one, notice my smallest number isn't on the left side. So I'm going to go ahead and rewrite this so that we have our smallest number on the left side. So 5 is less than x, which is less than 7. Make sure that your mouth facing x, facing x, facing x. Gotta say it. It works. Alright, so now my smallest number is 5. It's an open circle. Label it 5. My other number is 7. And everything in between. So not a whole lot of options. There's actually still an infinite number of solutions to that, though. Isn't that interesting? Because you have all the decimals, and you can constantly, like, you can do 5.000000001, but then you can throw in another 0, and it's a new number. Isn't that so interesting? All right, number 14. X is greater than 5 or x is less than 0. So again, 2 different statements here. So let's first deal with 5. X is greater than 5. Go to 5. Open circle. Greater than that. X is less than 0, so go to 0. Open circle. Less than that. So really we're just combining what we did last class with 2 different equations. That's what I was thinking. Alright, any questions with those? Okay, let's do some solving. Which is again, just like we did last class, just a little bit more work because there's 2 equations in one number. Alright, solving compound inequalities. If you have an or, so if you have an or inequality, solve it as 2 separate equations. So like we see for number 14, they're 2 separate, leave them as 2 separate. When you graph it, your arrows should go in opposite directions. Just like we've seen for every or statement. What we're doing now is we're solving. So we're saying once you get your solution, then make sure we go in opposite directions. If it is an and statement, then it is written as a sandwich. So like 2 is less than x, which is less than or equal to 7. Whatever you do to one side, you must do to the other side and the other side. So what's really cool with this is that we're actually going to, we still need to get x by itself. So we're going to solve just like we normally do, but now we have to do it to both sides of the equation, or of the inequality. And again, your graph should look like a sandwich. And then remember, if you multiply or divide by a negative, you must flip every sign in your inequality. So let's go take a look at a couple examples. All right, number 15. Is this an and or an or? It's an and. It's written as 1 inequality. So these are my favorite ones to solve here. So to get x by itself, what would we have to do? Move what? If I have to get x all by itself, let's say I just had x plus 9 equals 10. What would I do to solve for x? You would subtract your 9, right? Well, to get x by itself here, same thing, I still have to subtract 9. Now, this is the really awesome thing with this. We have to do it to both sides. Yeah, we're basically solving two inequalities at once.
Double the weight.
I love it.
It's actually triple.
Talking about.
So what we're doing is we're solving two inequalities at one time, which is, I love it.
So guys, if you struggle to keep track of that, you can draw lines underneath both inequality signs
That's
to
what I
easily
did.
track it.
Boom. Like what I didn't spend.
All right, so 0 minus 9, negative 9. We still have less than or equal to x. 9 and negative 9, those cancel out to 0. Less than, what's 17 minus 9?
38.
Close.
8. Good.
It was like smiling.
He's always such a happy rabbit.
Who?
Who?
What was that?
He teaches multivariable calculus and BC calculus. Algebra 1 is what you take.
No, calculus.
All right,
How hard is that?
it
was harder than
harder than this. All right, negative 9 is less than or equal to x, which is less than 8. So now, we haven't tell us anything about set builder notation? No. Make sure you're checking. It'll still ask you sometimes to write in set builder notation. Make sure you read the instructions because we're not always going to give you the number line. So sometimes it'll say solve and graph it, and you have to draw your own number line. So just be aware of that. All right, so let's go ahead and graph this. We have negative 9 and we have 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 8, 1, 2, 3, 4, 5, 6, 7, 8. All right, at negative 9, open or closed? At 8, open or closed? Open. And it's everything in between. So it's an and statement. We've got a really long 6-foot separator. Like I said. All right, number 16. Oh, I love these ones. Okay, what do we have to do to get x by itself? Divide by 7. And again, we do this to every single inequality, or every single piece of it. We're basically solving negative 14 is less than 7x, and we're solving 7x is less than 21. Just in one swoop. Good, so this is negative 2. What's 7 divided by 7? 1x, which is just x. And 21 divided by 7? 3. Again, our smallest number is on the left, so let's write 0. Negative 2. And positive 3. That's fine. Just as what I care about is that you have labeled the ones that have the circles. Okay. All right. Open or close circle on negative 2. Open. Both of them are open. Okay. It's everything in between. It's combined together. It's an and statement. All right. Questions on 15 or 16? Let's move on to 17. Finally, an or one. So or we just treat as two separate equations or inequalities. We can't combine them together, so we choose two separate ones. So let's first solve the left one. How do I get x by itself?
4.
Good, add 4. Those cancels out. X is less than negative 8. That's one of my inequalities. Now let's do the other inequality. How do I get x by itself over here? Divide by 2. So I have x is greater than or equal to 6. We must write or in between. Do not forget that little 2-letter word. It's extremely important. Okay, so let's go and graph each of these individually. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. Alright. Negative 8, open circle. X is less than negative 8, pointing to the left. Everything less than that is to the left. Greater than or equal to 6, so we have a closed circle. Everything greater than that, that's everything to the right of it. The arrows point to the right. We point our arrows right. And we're done. Alright, questions on that? I'm gonna do 21 with you, and then I'll have you do. Oh wait, not 21. I'm gonna do number 18 with you guys, so you can see what we need to do when we encounter that negative. All right, so number 18. What's my first step here to get x by itself? This right here. I need to get x alone. So what else is with it? -6. It's currently a negative, so in order to get rid of that, we need to add 6 to both sides. And to this side. Alright, -5 plus 6. -6 plus 6 cancels out. Notice we still have a negative x. A lot of you lose your negatives. One of the most common mistakes I've seen all year long. And then 3 plus 6, what does that give me? Okay, fine. I'm going to wear the funny thing up here, but please. Nice. Alright, Joe.
Yeah, Joe.
We've got a negative x. How do I get rid of a negative? You want to add the entire x over, but then that leaves us with 0 in the middle. We want to leave our x there. I currently have -1 times x. What do I do? Good. In order to get rid of that, I need to multiply or divide by -1 on both sides. 1 of all 3. 1 divided by -1 is -1. Now, whenever we multiply or divide by negative, what do we have to do? Flip it. This becomes a positive x. We have to, 9 divided by -1 is -9, so we have to flip that side as well. If you don't divide by negative, you don't have to flip it. You only flip when you multiply or divide by negative.
Just like leave the X.
What if you what?
Leave the X.
Leave it.
Leave the X.
Then that would give you the, like when you would graph it, then you'd have your solutions are 1 to 9, but you have to get x completely by itself. Okay, so again, we like to have our smallest number on the left side. So what's smaller, -1 or -9? -9. And also notice my arrows are pointing that other direction. So we're going to flip this whole thing around. So -9 less than x, which is less than -1. That is your symmetric property. That's true. Again, the mouth is eating the x and eating the -1. So it should be eating the x and eating the negative. Alright, let's go ahead and graph this. You did beat me. Alright, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. -9. -1. Trey, did you have open or closed circles? Good, open. And it's everything in between, so we can have those two. Alright, questions on the ones we've done so far? Alright, I want you guys to go ahead and do 19, 20, 21, 22, 23. Yep. So I want you to do those last 5 problems. Make sure you take note of when it's an or statement, when it's an and statement. Give you until 11 o'clock to do that, and then we'll come back together and go over those. All right, here's number 19. We have an or statement. So we have our answers are going in opposite directions here. All right, so we have to subtract 6 from both sides, and then divide by 2. We got x is greater than 7. Subtract 8 from both sides, and we got x is less than or equal to -8. Make sure you still have your or statement. Any questions on 19? Okay, so now number 20. Went through into the work here, but then when I went to graph it, I saw x was less than -16, and I also had x was less than or equal to -5. And that would give me 2 arrows in the same direction, which we've never encountered. So can anyone find what my mistake was here? What's the mistake I did in number 20? proceeds with the mistakes?
Still facing the same way.
They're facing the same way, but what caused me to make that mistake? Morgan? Right! Notice I divided by a -3, and what did I fail to do? I did not flip the sign. Make sure whenever you multiply or divide by a negative that you flip that sign there. And if you forget, but you have to graph it, you can usually catch it when you see that error in the graph. So we should have had x is greater than or equal to -5. Then that gives me arrows in opposite directions. So when I go to graph this, now I have that they go in opposite directions. So use that common sense there to kind of help you out in knowing what you should expect to see so that you don't make mistakes like that. All right, questions on number 20. Okay, go ahead and do the other ones here. All right, so 21, we have to subtract 5 from both sides. So I get -18 is less than or equal to, those cancel, -2x, which is less than 4. All right, Joe, what's my next step? All right, Joe, you're going to take the next step after that.
Yeah.
Too long. -18 divided by -2 gives me +9. Now, what do I have to do with my inequalities when I divide by negative? Flip them. Good. That cancels, or that reduces down to 1x, which is just x. Flip that guy as well. We have. We need to go ahead and move this whole thing around so that we have our negative on the left side. Alright, so now let's go ahead and graph this. We have -2 and we have 9. 0, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Close circle at 9. Open circle at -2. And statement, so we should have that same virtually graph. Alright, number 22. Alright, Joe, what's going to be my first step for number 22?
What is it going to be?
Divide the 11.
Okay, divide by 11 on both sides. So I get -2 is greater than x. What do I have to do to the right one?
-4.
Yep, subtract 4. Let's cancel, so I get 4. X is greater than 0. It's fine to get 0. I mean, that can be part of our solution. Alright, so we have then 0, and we have -2. Or statements, they should be going in opposite directions. So let's go ahead and rewrite this one so that x is on the left side. X is less than -2. Or x is greater than 0. That'll help us out with the arrows. Open circle to the left. Open circle to the right. Wait, questions on 21 or 22? Nope. All right, number 23. Again, another or statement. Kevin Perez, what's going to be my first step for number 23?
We'll do it when it's done.
What's my first step for 23, Kevin? And Alex says she'll be after. What do I have to do to get x by itself? We don't want to divide yet. We still have to get rid of everything else around it. Subtract what?
11.
Subtract the 1. It should be pretty straightforward now. We've been doing solving for so long. We have to get the x by itself, so we get rid of addition subtraction first. Subtract 1. So we have 2x that is greater than 12. Now I can divide by 2. I need to split those up. Divide by 2. Get x is greater than 6. Alright, Alex, what's my first step on this side? Good. Subtract your 3 over. So I get -21 is greater than 7x. Those cancel. And I can divide by 7. -21 divided by 7 is -3. And these stay as or statements. Let's go ahead and rewrite it so x is on the left side. X is greater than 6. Or x is less than -3. There's no 0. 1, 2, 3. There's -3. 1, 2, 3, 4, 5, 6. Here is 6. Open circle on 6, it's greater than that. Open circle on -3, it is less than that. Alright, any questions on 23? So just a reminder, you will have a mini quiz on this next class. I'm going to go ahead and pass out your homework to you, worksheet 4, or sorry,
It was due
worksheet
Friday.
6.
I mean, it is due Friday.
This is due next class. We'll go over questions on it before we take our mini quiz.